Hey, Algebra 2, I'm going to teach you how to solve exponential equations. So the basic steps are you need to write them using the same base. Like if I have x to the fourth, the x is what the base is, and the 4 is your exponent. And so then if we can write it so that if your bases are equal, then your exponents must be equal. And then we just set the exponents equal and we solve. So I have a base of 2 and I have a base of 8. So you're always going to look at the bigger number, and can you write 8 using a base of 2? Yes, 8 is 2 to the third power. So I think probably the most difficult part of this is trying to get your number sense about you. So on the left, it's just 2 to the x. And then on the right, I'm replacing the 8 with the 2 to the third power, what I figured up here. And then you still have this exponent of a 3. So what you have to remember is that when you have an exponent raised to an exponent, the correct action is to multiply them. So 2 to the x, 3 times 3 is 9, equals 2 to the 9th power. If your bases are equal, then your exponents are equal. So you just set them equal, and in this case, you didn't have to do anything. So how do you check these? Let's just plug it in. Is 2 to the 9th power the same thing as 8 to the 3rd power? These are really, really big numbers, but just put it in your calculator. Put 2 to the 9th in, see what that is, and then put 8 to the 3rd in, and you should get the same answer, and yes, it does work out. All right. My bases are 9 and 3. So you want to write 9 as 3 to the what power? That's the same thing as 3 to the 2nd power. So your first move is that I need the same base. So that's 3 squared. And then bring down your 2x minus 1 exponent equals 3 to the 6x power. When you have an exponent raised to an exponent, you multiply them. So 2 times 2x is 4x, and 2 times negative 1 is negative 2. Now that your bases are equal, you're going to set your exponents equal, and then we're just going to solve. So 4x minus 2 equals 6x. So now we have to do some algebra and we have to solve. So I would subtract the 4x over negative 2 equals 2x. Divide both sides by 2, and negative 1 equals x. Let's check and see if it works out. So 9 to the 2 times negative 1 minus 1 equals 3 to the 6 times negative 1. 2 times negative 1 is negative 2, minus 1 is negative 3. 6 times negative 1 is negative 6. You put it in your calculator, and it works out. It's like 0.00137 equals 0.00137. All right, so all of this is really just about number sense. You look at the big number and ask yourself, how do I write that using the base of 4? So 64 is the same thing as 4 to the 3rd power. So you do that one, and you should end up with 2. I want to jump back to number 5. Number 5 has fractions on it. So we have to use the property of negative exponents. If you have 1/5, that would be the same thing as 5 to the negative 1. I'm just using my negative exponents property. Because this is the only way that I can get them into the same base. So sometimes you will have to rewrite both of the bases in order to get a common base. So 1/5 is the same as 5 to the negative 1. And then I can write 25 as 5 to the second power. So my common base is actually going to be 5 in this one. So 1/5 is 5 to the negative 1. And I still have an x minus 5. 25 is 5 to the second to the 3x plus 2. When you have an exponent raised to an exponent, that means that you have to multiply. You're going to need to remember to distribute it to both of those numbers. So that gives me a negative x, and that negative times negative gets me a plus 5. Distribute the 2, and I get a 6x plus 4. Once your bases are equal, you're going to set your exponents equal. And then it's just a matter of doing algebra. I would add x to both sides, and I would subtract 4 from both sides. So 1 equals 7x. Divide both sides by 7. And x equals 1/7. You plug that into your calculator, and I assure you that that does work. Let's do one more with fractions. Okay, so I have 1/2. So using my properties of negative exponents, I know that that's going to be 2 to the negative 1. So I want to get the other number using a base of 2. I can do that because 8 is 2 to the third power. So now I have a common base. So I have 2 to the negative 1 to the 4x plus 1 equals 2 to the third to the 2x plus 1. You're going to have to distribute your exponent. So that gets me negative 4x minus 1. 3 times 2 is 6x, and 3 times 1 is 3. If your bases are equal, that means your exponents must be equal. So then I'm just going to do some algebra, and I'm going to solve. I'm going to add 4x to both sides, and I'm going to subtract 3 from both sides. So negative 4 equals 2x divided by 2. So x equals negative 2. Okay, that's totally wrong. That's why I always have an answer key. Okay, so 6 and 4 is 10x, my bad. So let's divide both sides by 10. And, oops, there we go. Negative 4/10 is the same thing as negative 2/5. Negative 2/5 is super hard to check your work. And so if you were going to check it, I would probably switch that to a decimal and use negative 0.4. So let's make sure this works. So I have 1/2 to the 4 times negative 0.4 plus 1 equals 8 to the 2 times negative 0.4 plus 1. So in my calculator, I went 4 times negative 0.4 plus 1, and that was negative 0.6. I did 2 times negative 0.4 plus 1, and I got 0.2. So in my calculator, I had to go, I either did 1 divided by 2, or you can just switch that to 0.5. It's probably easier to go 0.5 raised to the negative 0.6 power and hit enter, and I got about 1.51 on my calculator for both of them. So that is how you solve equations by getting the same base.